Okay, so good afternoon all. This is the third class on linear classifiers. What did we discuss in the previous class? We were discussing how to find out the line, right? That separates one class from the other. So how can we learn this line? Given a set of, let's say, you have been given a training data. We were calling it as, let's say, x1 and x2, and given some samples, how do you compute the line that separates one class from the other class? This is what we were doing. What was the equation for that? W bar transpose into x bar plus W naught. This is our G of x bar. Right? This was the line we have seen. All the relationships of this weight and all those rest of the things we have seen, which was the particular algorithm that we were discussing in the last class. First, finding out this line. What was the algorithm? Gradient descent is the algorithm we were discussing there. And of course, also mentioned few variants of gradient descent also, where you do the update by taking each point rather than looking each misclassified feature vector, to be more precise, instead of taking summation over all misclassified feature vectors. Right? That's what we discussed. Now, next part we will do now is, now assume that we did this now, we got a line. I give you a new point, x bar. This is, now it's, you are at the doing it, I can call it as a testing phase, or this is where you are going to use your algorithm. So what is the process you do here? Let's say, still let us restrict to a two class problem. I have class A and class B. I have given you this line. How do you do the classification? I give you now this line. Okay, you know this line now. Now I have given you an x bar. How do you figure out now? Let us call this as class A and this as class B. How do you figure out now whether a given new feature vector belongs to class A or belongs to class B? As simple as that. For example, it could be that class B, one of them is positive. So let me put AB without loss of generality. Okay, this side may be positive and this is negative. Then what you will do, for example, if G of x bar is greater than 0, you will say x bar belongs to class A. Otherwise, I could write, or let me write for the sake of completeness, then you will assign it to nothing to do with your calculation of weights is already done. What is it that you are getting at the end of whole training is you are computing W bar and W bar. That is what essentially happening. That you already know. And of course, as you said, you could compute for a given point R bar also. That is another way you could do, but even simpler is just to see, you just substitute just W bar, you might be already having the weights there. You should be having the weights, not maybe, should be. Like you substitute your x bar value, see if it is greater than 0 or less than 0. Fine? Is that clear so far? This, even the algorithm we were mentioning is as perceptron algorithm, by the way. We haven't gone to much of the details at the time. Neither now we will go to much of the details of the perceptron. But yes, we will say that perceptron, we could think of it is as a mathematical model of a neuron. Say again, there is a nice theory behind how they correlate this or inspired initially to begin with from a neuron, which has kind of dendroids, if I'm not wrong, kind of sensors which gets information from multiple things, and each signal that it gets from each dendroid, it applies a weighting factor. Okay, And then based on that, a decision is taken by a neuron. That is how to keep it in a very trivial way. Okay. So the weight factor comes from W bar. The signal taken by each of them comes X bar. And yeah, there could be some bias also added. You might have some prior bias. Okay. I could still use the same mathematical word to a generic word that is given by W. So that's how the same. Okay. So when it comes to this, doing it after I get W bar, there is a now the perceptron model, the way they represent it. Let us try to take a look at it's kind of a block diagram. Let's take it. All right. Okay. Say I have x1, x2, x3, and so on. I'm in an L-dimensional space, so I have L feature vectors. I have xn. Okay. And what is happening here is I need to. So just can you expand and tell me now what is this if I have to say it as a scalar instead of multiplication of two vectors, w1 x1 plus w2 x2 and so on plus wl times xl plus w naught. That is how I could simply write my discriminant function, isn't it? So what I will do here is all these things will be given as inputs to one neuron. So I'm going to still I will draw it as a mathematical model. So what I will do here is just trying to see the way these points are represented there. So let's say the reason I'm not very sure if they use the diagram to show it, just we follow that. So you are going to sum them up, all of them. And while you're doing it, you all know with the graph representation, typically what you do is the weights are kept on top of the edge, if you call it as an edge, the line in general, you keep that here. So this one will be multiplied with the W1, this one will be multiplied with the W2, W3, this being WL. So the output here is what is, and is that good enough or something else I need to do here? Bias I need to add. So that is bias. Where are they keeping it? Yeah, still it's up to you. You could keep that as here W, right? So this you are getting now. What is the output here? W1 x1 plus W2 x2 and so on till WL xl plus W naught. And how are you taking a call? You are looking at whether this function is greater than 0 or less than 0, right? Say, so there is a function you are applying to this, which will give you an output, let's say call it as y here, and assume that I call class A represent with 0 and the class B I represent with 1. So my y could be 0 or 1. What do I have at this point? It can be a value, any value it can be, but at the end I should get 0 and 1, let's say. Okay. There is no reason why I should stick to 0 and 1. I could have even considered -1 and +1. Doesn't really matter. It's just a number that tells you that it belongs to a different league or a different class. That's all. So given this output, what is it that you could suggest here, which gives me 0 and 1? See, this is the summation I got here. This I am giving as an input here. What could be this function? Can you name some function which eventually gives me 0 and 1, depending on if it is greater than 0 and less than 0? Okay, maybe for some simplicity, let me call this as 1 and 0. There is nothing wrong. I could have done the other way also, but you will realize why I'm doing it this particular way. What could be this function now? That's it. This could be, for example, a simple step function, which, okay, so let me anyway x bar here I'm using, let me call this as m, okay. So then here I have f of m. If the input to it is negative, means for all values of m here, this is 0 here, and then for any value of m greater than 0, this function is going to take a positive, okay. And this is referred to as, I'm sure since some of you would have done either in the other course or would have even seen, any idea on what this is referred to as? Like, this is referred to as activation function. As we move on, you will gradually realize that this is not the only way of just going to 0 and 1. There will be instances where this plays a vital role and you keep playing, okay, in an informed way, and to see to get a better solution to your result. But anyway, let's keep that in hold for some time now. We'll come back to that later. So, is it clear so far? This is the mathematical model of the perceptron, or the mathematical model of a neuron, which is referred to as perceptron. Again, if you look at the literature, there are various models of perceptron, but again, for our purpose, this is sufficient. For now, we look at it this way. Okay. Another, hope this is visible here also. Right. So another way that people represent this also as, I have x1, x2, and so on till xn, and they will just take a single circle here, we add them all here, and to this itself we will add w0. Of course, here this is w1, w2, so on here, wn, and this itself you write it as your y. So, which means it is something that is combining or merging both the summation module and activation function module. This is also another representation that you would come back. So this is something where you can call it as summation. Of course, in case of, it would have been an integrator if it hasn't been a continuous signal. So it's fine. You could call it as they were calling it as a linear combiner also. Another name that people commonly using is this. They are calling it as a linear combiner, and this as an activation function. That's how people are calling it. This is something that merges both the linear combination and your activation function. Also, you can see step function we are using as this. Right. This is something. Let's see some examples. Let us take a two-dimensional feature vector, my L equal to 2. So my x1 and x2, let us have those values as 0, 0, 0, 1, 1, 0, 1, 1. Well, I am using 0, 0, 0, the binary numbers. By that, don't get misled that this is applicable only to a binary system. You could interpret it equally, the case where your x1 is less than a particular value and your x1 is greater than a particular value. After all, if I multiply with any constant, that's what it is going to happen. So any value less than that, more than that value also, it is equally applicable. So please keep that in mind. Otherwise, it may give the impression that the whole thing is you can do when your x1 and x2 are binary values, which is not at all true. That is a very specific case with limited applications. That's not what we are going to see. Okay. Now, let's consider that, see, keep it in mind that what are these feature vectors? For example, I want to classify people into two groups. Okay, and the kind of groups I might be looking at, okay, might be characterized by the height of the people and the weight of the people. For some weird reason, I am looking at body mass index and healthy versus nutritionally something is required. So I assume I am doing something like that. I might look at your height, I might look at the weight, and also perhaps the age. These could be three vectors that I am looking at. So those vectors are nothing but here x1 and x2. Okay. Again, still let us restrict ourselves for now to two where I have feature vector of size 2 and I am doing just a two class classification. Right. Suppose the result of how I do is for somebody, you should have for some special classification, I need both this and that should be there, then I will put him in one class. You should have so and so height and so much of weight, then I put it into a particular class. If not, I will put it into some other class. Okay, that could be one example here. So anyway, consider that essentially my classification is at the end of the day is based on having both features greater than some value. As I mentioned, 0, 0, 0, 1, these numbers you could attribute to the other values also, not necessarily the y. Okay. So what is my y value here? If it is an AND operation, what are my y values? So both should be there, otherwise I put it into another class. So let's say 1, 1 only is, it should be this as well as this. Okay, then only I'll put him here, otherwise I'll put 0s. This is another class. 0, putting 0 means it only says that I'm putting it in the another class. Right? Now, can you now, based on this, can you tell me what would be the line that classifies into these two classes? Is it possible? How should I approach that problem now? I want to see a line, a linear classifier. Depending on these x1 and x2, this is the outcome I want. So how do we approach this problem now? So we should first draw a graph and see where these points are there, then we can figure it out. So let us call this as x1, x2 by features. You can have either 0 or 1. This also can have either 0 or 1. Okay, both are 1, then I would put it into class A. So this is the point which I put it into class A. So I'm right away first looking at this among all these entries in this table. Then 0, 0, that means x1 is 0, x2 is 0. I'll put this into the another class. Let me call this as A class, another class as B. 0, 1, 0, 1 is this. I'll put it into again class B. What else? 1, 0, that means here. Okay, that also I'll keep that into class B. This is also B. Is it possible to linearly separate these guys? You put any line here that separates these two, and that will suffice, right? So, well, what could be this? For example, this is 1 here. Okay, suppose I have a what could be here? Suppose if I have, okay, so then let me take 1.5 here and maybe 1.5 here. Hopefully that is just check any line, okay, that is in between this and this. Okay, this just you can look at what could be this value, you know this, okay, you can figure it out. So any line in between would be sufficient, and I trust what you guys are telling me. So I could put x by 1.5 plus y by 1.5 equal to 1. Okay. Of course, I could consider lines with different slope also, as long as they separated. Okay. So this could be, for example, 3 by 2, right? 2x plus anyway, x plus y minus 1.5 equal to 0. Isn't it? That's all, right? Just to, if you want, how can I check that out now? Put a equal to 1, 1 here, both 1, 1, 2. 2 minus 1.5 is 0.5. So greater than 0. Put some other point here, 1, 0, one of them being 1. 1 minus 1.5 minus 0.5 negative. 0, 0 minus 1.5 negative. 1, 0, 0 1 would give you the same thing. So thanks, you guys helped me here without making a mess. Me making a mess here. Okay. Now, can you tell me what are the weights now here? What is my W bar vector here? 1, 1. And what about W naught? W naught is minus 1.5. Which one? Yeah, sorry. You're right. Thanks. I should have written here x1 and x2. Good. This is x1 plus x2. Okay. Always in the mind, this is x and this is y is there. But yeah, x1 and x1 plus x2 minus 1.5. Right? Is it fine? Any clear? Please do it now for, first of all, see, can you do a similar workout for R now? It is like now we have a more relaxed one who is kind of one class is it is enough if he has either feature vector 1 or feature vector 2. If he is having both, wonderful. Even if that is not the case, having one is good enough. Okay. So again, as I said, always keep the interpretation that 1 means anything greater than that particular value. That's how you could interpret it. So what is my x1, x2, and the output expected? It could be 0, 0, 0, 1, 1, 0, 1, 1. It means this is less than, both less than, both greater than, this kind of things. Okay. So either of them having is good enough. So that means either 1, 0, 0, 1, 1, 1. I'll get that. And this is the only case we throw that guy out. 0, 0. Okay, he is not qualified for any of these two. Okay. So again, can I go this side also? Here I could see, right? Very good. You could see the line. Okay, good. Now, draw a similar stuff. X1, X2, 0, 1, 1. Now, let me first do class B here, 0 being class B. That's why I'm considering. So this is the only one that gives me B. 1, 0 is A. 0, 1 is A. And 1, 1 is A. Okay. Can they be separated with a linear line? It is easy to see for me now because I don't have to approximate the value. Between this, it will be 0.5 and 0.5. Okay. So x1 by 0.5 plus x2 over 0.5 is equal to 1. That means x1 plus x2 minus 0.5 is equal to 0. That's all. This also you could do the linear classification. Any questions? Or is that clear? We will take now. So you could see here, there is just to, maybe I will now try here as I can continue my further narration to this board itself. So let me just summarize or consolidate the results I got so far. My x1, x2, they can take values 0, 0, 0, 1, 1, 0, 1, 1. And when it came to the AND case, this turned out to be the discriminant function for an AND case, correct? And for an R case, so this is R, we got it. Now let us take another one, exclusive R, XR. How does XOR work? Third example, XOR, X1, X2, Y, 0, 0, 0, 1, 1, 0, 1, 1. A bar B plus B bar. Yeah, I'm sure you all have done digital systems course, right? Only A times A bar B plus B bar A. One for the terms to be non-zero, they should be different because you are taking complement every time. So this would be 1 here, and this will be 1, and the rest will be 0. Right? Now you find out here the line that separates these. What's the case here? Maybe anyway I have drawn here on top of it. Let me draw that 0, 0 is 0. So this is my class A. 0, 1 is 1. So this is my class B. And 1, 0 is 1. This is my class B. And 1, 1 is 0. This is my class A. Now what will be the line that separates them? No line? So in the single neuron model, solve this problem? No. What should we do now? 2 lines. Okay, I give you these 2 lines now. You have already given me those 2 lines. One is x1 plus x2 minus 1.5 equal to 0. This line is there. This line is there. Then what? So think in terms of the perceptron model, how you could achieve that. Even before that, you want to get 2 outputs here in the first place. At least it is clear till that extent. Correct? So what is it that you plan to do? This part is visible. So I will do that here. What is at least clear so far is, let me have 2 neurons instead of 1 neuron, because each neuron is giving you 1 line. Correct. So now I need 2 neurons, at least clear till that extent. Correct. So I have, how many inputs are there? 2 inputs are there. One is x1 and another is x2. Now this I will feed, this I will feed here, and of course there is a, this term is also there. Okay. And now I use the second model that I have drawn. Just I don't keep activation function, everything together. This is my neuron. Okay, just for the sake of convenience. Okay. Similarly here also, I'll give this as an input, this as an input. I have another one here, right? Say this is my x1, this is x2 here, right? For example, this is the one I wanted. This is again some abuse of notation I'm doing. I'm writing it for you to clearly see that is doing what AND is doing. This is doing me what OR is doing. Okay. For AND, what did I get there? X1 plus x2 minus 1.5. That's what we got. Okay. So this is 1 here. This is 1.5 here. And what about this? Sorry, this is 1.5. Sorry, x1 plus x2. This is minus 1.5. Right? X1 plus x2 minus 1.5. What about this R that I got as a result here? My x1 plus x2 minus 0.5. So this is 1. This x1 coming is 1. And here minus 0.5. Okay. Now, what is the, so let me, so I got 2 outputs here, y1, y2. I have 2 outputs here instead of 1 output now. Correct. Now, so this is what I need to achieve. That we will keep it like this. But let's see what I got in y1 and y2. Right. So I have, let me write it as here, y1, y2. y1 is AND gate. So both should be there. Then I will get 1. The rest are all zeros. OR gate, it has to fail in both places, then only it will be 0. And otherwise, I have 1 here. these two, I should now deal with them in such a way that, say here, this is, let us call this as G1 of X here, as you are mentioning, G1 of X2 bar, G2 of X bar. Let's say this side is positive. So for this line, this side values are positive and this side are negative. Here this line, this side is positive and this side is negative. So what should happen now? Look at these outputs. Earlier, so you have 0, 0, 0, 1, 0, 1, 1, 1 now. If you look at the outputs of Y1 and Y2. And what should happen now? Look at here. Can you make an interpretation here? What is my output required? Well, when it is 0, 1, my Y1 and Y2, then it is 0, 1, I should get 1. I'm just copying this only, but in a different sequence to make the interpretation clear. I'm writing here. When my Y1 and Y2 are 0, 1, I should get 1. Otherwise, for any other outputs, I should get zeros. So maybe for a easier visualization, let me put here Y1 and Y2. I could have all, now look at here. The possible values, combinations have reduced here. They are just 0, 0, which belongs to class 0, which means that's called, that will be here, which is, let's say, what is it that we are calling? A, right? We are calling that as A. Okay. Then 0, 0, 1. Okay. That is another class which is belonging to B. And what is the other one? 1, 1 that belongs to 0. 0 means can you separate them now? That can separate. Is it not? Or did I write that correctly? Yes. You could separate them now. So what should you do now? Again, these are the inputs and simply have one more neuron to which you feed the outputs of Y1 and Y2 and get this line. To again summarize, originally, if you use a single neuron, they are not linearly separable. Now what you did is, instead you have given to two neurons and the outputs of that, if you look at it, the desired output is now based on these values which you are getting are linearly separable. So this equation now again is very easy to find, right? This is 0, 0 here. So what could be that? You can put, so I just 1 by 2 and 1, for example, here if it is 1 by 2 intersection here and a -1 intersection here, if you take, okay, in between I am taking, so that will be x over 1 by 2 plus y, again, sorry, x1 over 1 by 2 plus x2 over -1. Okay, this is equal to 1. That means x1 minus 2x2 is equal to, so I'm just multiplying with the 2 here, so that will become x1. Here 2 minus 2x2. Okay, here it is equal to 1. No, 2. Is that correct? So anyway, sometimes x1. Okay. Yeah, you just looking at 2 I multiply. So 2 gets cancelled. x1 minus 2 I multiply. Hope it is correct. Okay. 2 x1 minus 2x2 equal to 2. Is it correct? 2x1 minus x2. Is it? The line has to pass here. Huh? Okay, right. So you are taking it this way. Okay, sorry, yeah. 2x1 minus x2 equal to 1. Yeah, thanks for that. So 2x1 minus x2 is equal to 1. Correct? This is fine. Yeah, y1 microaction. Correct? You mean this is y1 and y2. Is it what you are mentioning?
0, 1, right? So, B has to be on ideal axis.
Which one? B point. Right. So these two, 1 minute. So 0, 0 is going to 0, right? So this is going to class 1 class, and 1, 1 is going to the same class. This B point is 0 and 1. Oh, yeah, sorry, correct, right. So this is 0 and this is 1. This is the point, right? So then my line should have not been this way. How should it be now? This way, yeah? Hope we are doing it. I hope I didn't mess up here. But anyway, just check the numbers there. Okay. So then it will be, perhaps you might get x1 minus 2x2 equal to 1. Or something, y1 I should write. So please check that calculation here. Okay, something like this you will get. So this is your y1 and y2. Now all you need to do is have one more thing here, where this will be an input, this will be an input, and then of course, how I will plot in here, there is one bias here you get, and let's call this as y. You are getting the desired output there. This is how, this is nothing but we already moved now to nonlinear classifier. We are able to classify something, set of points which cannot be separated by a single linear line, by considering multiple perceptrons and combining the output coming from those multiple perceptrons. Okay, I'll any question here? We will further continue this discussion in the next class. But before that, is this idea clear? And by the way, this is referred to as, I'm sure some of you have been knowing it. What is it referred to as? This layer of all neutrons?
Hidden layer.
Not neutrons. Neurons is referred to as hidden layer. And maybe I will leave you with just pointing your observation to one thing here is, when you look at this level, it is taking all the points within that region, but on the contrary, when you are coming to the next layer, all those points are already mapped to the vertices of a square. Please pay attention here. Although I considered 1, 0 here, go to a very general case. For example, you could think of it as, I have one class of points here, another class of points here. Okay, and now I want to do the classification. That could have been the problem. Now, when I look at things at this layer, the inputs can be anyone in this region. And for the other class, any points in this region. On the other hand, when I move here to this layer, if you look at the inputs, what do I get out of each thing? Either 0 or 1. Correct. So the inputs to this are just the vertices of a square. Had it been x1, x2, x3, it is not necessary that all vertices of the square should be there. Of course, for example, here you don't have this vertex. The wrong one which I have plotted earlier is not there. If you consider the square, all the rest of the 3 vertices of your square are there. And we considered if not XR and something else, this could also come. It is possible. Okay, but important point to note here is this first hidden layer, the input can come from any point in the region. On the other hand, to the next layer when you commit, come to the next layer, the input comes just from the vertices of a square. Had it been feature vector with size 3, it could have been the points on a cube, vertices of the cube, not anywhere in the cube, it cannot come, right? Or for higher dimensional space, we will call it as hypercube. Only the vertices of a hypercube are inputs here. Is the point clear to you? It does have a consequence, which you gradually realize. And now, just one more point to conclude with is, it may so happen that sometimes you will be able to separate. All you are doing now in this layer is to just separate the vertices, not anymore the regions, because all your points already got mapped to just the vertices, isn't it? So it is enough if the hypercube, to keep it in general, separates the vertices into two desired groups. And it may so happen, suppose in my vertices here, if I had got this point also, again it appeared here for some other combination, then I can still won't be able to solve this or separate these vertices also. It is not always guaranteed. Then what you do? You repeat the same process. You can have more layers here, nothing stops you. And similarly, you can have more layers here. And then you combine, you do it until you arrive at an instance where your vertices can be separated. Hope this intuition is clear. And of course, this is all based on the assumption that you are using a step function there as your activation function. You will see later points. It is not the only way you use. When you use something else, then they might not stay. You might not be getting just the vertices. Okay, so I will stop here.